section 12.2, arithmetic. It's still arithmetic, so we're adding a constant each time, but now it's series. So the word series, whenever I see that word, I'm going to put, sum next to it, because I just want to make sure that you know that series means that we're adding up those numbers. Okay, so, and there's a notation that goes with it. So I'm going to tell you the formula. Here we go. And then I'll label what each part means. So the sum of the first n terms in a series is equal to. And this comes from the Gauss story of, remember he wanted to add the numbers 1 through 100. So what did he do? Well, he paired up the first term and the last term, right? So he did a sub 1, first term, plus the last term, a sub n. And then he did that, he just multiplied by 50. So the number of terms divided by 2. And that gives you the sum of the numbers 1 through 100 quickly. And that is the formula. Now let me label each part for you. So this notation, S sub n, means the sum of the first n terms. Sum of the first n terms. N is just the number of terms that you're adding. Number of terms. A sub 1 stands for the first term. First term. And A sub n stands for the last term. Last term. So let me show you how easy this is to use. We'll do 3 examples. They will all say, find the sum. Find the sum. And you're going to you'll see this cool sigma notation that looks like this. Sigma or summation notation. So you'll just see this symbol that looks like that. And you'll see the index. So for the first example, we want I equals 1 to 12. So how many terms are there? 12. And then you'll see some expression here. In our example, we're doing 2 plus 7i. And that's the first problem that we need to solve. Find the sum. So what this is saying is add up these 12 terms, and you get the terms by plugging in the index number into this expression. So let's just try to use the formula. So the sum of the first n terms. So we go S sub 12, sum of the first 12 terms, because we know that because it goes from 1 to 12, equals, n is the number of terms. You just told me it was 12. So that a 12 gets plugged in for n over 2 times. And now we need to find the first term and the last term, and then we'll have it. So how do we find the first term in this series? You plug in a 1. Exactly. So a sub 1, the first term, equals, you just plug 1 in for I. So it's 2 plus 7 times 1. And then the last term, that's 9. And then the last term, a sub n, is you're going to plug in 12, right? The last index. So that's just 2 plus 7 times 12. And that will give you 70 plus 14, 84 plus 2, 86. Alright, and those are our numbers we need for the formula. First term plus last term, so we just go 9 plus 86. And you have to evaluate this correctly. The order of operations, you do parentheses first. Okay? And then you divide this, and then you multiply them together. So just be careful that you do that correctly on your calculator. You should get 570 as the sum. That is the sum of the first of all the terms in the series. And there are 12 of them. Without having to, otherwise you would have to expand this whole thing and write out 12 terms and then add them up. That's too much work. Okay, so we're going to try one more like that. and then we'll do something different related to a new TV series that's coming out. The new season starts tomorrow night. I'm very excited. Yes. House of Cards. Okay, so I equals 1 to 28 sigma.
Why is it 9?
Oh, so that's a great question. Why is it I? It could be any letter you want. It could be K, it could be J, it could be T. It's just a variable. So you just I is nice because I is the first letter in the word index. So it's like an index. And you use it in computer science a lot. We like to program using the variable I. Okay. So here we go. The sum then of the first of the 28 terms, all 28 terms. We go like this. S sub 28 equals 28 over 2 because there's 28 terms. And we just need the first term and the last term to add them up and we'll have it. So the first term, A sub 1, we just plug in 1 into the index, negative 2 plus 4 times 1, and that gives us 2. And then we plug in, we want the last term, so we plug 28 in, negative 2 plus 4 times 28, and that gives us 110. So we take those two numbers and we add them up in our formula, first term plus last term. And if you do that correctly on your calculator, you should get 1568 for the sum of the first 12 terms. Now, so any questions so far? Okay, let's do an application for the last one related to House of Cards, which is very timely. I love it when that happens. So number 3 is find the sum of the first 14 levels of the House of Cards. Find the sum of the first 14 levels. I'm going to draw you a picture. Yours is going to look better than mine. Sum of the first 14 levels of this House of Cards. I don't know if you've ever seen someone stack cards, but this is what our House of Cards is going to look like. So draw a picture like this. Okay, on the top level of your stacked cards, you're gonna have 3 cards like that on the top level, and then supporting each end of these 3 cards is going to be another 3 cards. So you have 3 cards here and 3 cards there. That's the second level. And our third level of the House of Cards, we support that there, that end there. We support the middle of those 2. You could think of it also as a cheerleading team. I'm not sure they would stand like that, but something like that. Okay. And now we could draw this picture down to 14 levels and count up all these little lines, or we can do it faster like this. So the first level you see is 3 cards, right? Let's look for patterns. How many cards are in the second level? 6 on the second level. How many are on the third level? Oh, I see an arithmetic series. ... right? But we want to get to the 14th level, so the sum of the first 14 terms is n over 2. Here's the formula.
Wait,
okay, there's 3 cards on the first level. There's 6 cards, 1, 2, 3, 4, 5, 6, and there's 9. So sum of the first 14 is n over 2 times the first term plus the last term. What's the first term? 3. What's the last term? How many cards are on that 14th level? I'm not sure. So what I need to do is use what I learned about sequences. So if I want to find the 14th term, I need to work backward, right? Let's practice what we learned. What would be before 3 in our sequence if we were doing sequences? What comes before? 0, right? Okay, and what's the common difference? 3, right? So we can do we can use sequences here. The nth term is going to be the 0th term plus 3n, otherwise known as just 3n. Okay, so we get to bring in, it's a multi-step problem where we get to bring in what we learned about sequences into series. So this is the formula. I can find the number of cards on any particular row with this formula. So I want to know the 14th. I want to know how many are on the 14th level. So I just do 3 times 14. Yeah, 42. Great. So 42 is that number that we want in our formula. So if you throw that in there and evaluate this carefully on your calculator, you would get 7 times 45, or there are 315. If you take the sum of all of our cards in our house of cards, which we might be watching while it's raining this weekend, we would get 315.